Good morning, dear listeners, and welcome to today's class. We strongly believe that you had a very wonderful night rest. Today, we are here again with you to continue to make efforts for you to understand mathematics and statistics. Today, we have brought before us problems that connect indices and logarithms of what of number. Because, of course, you should be aware that no effort should be enough in teaching students the relationship or the links between logarithms of numbers and indices. Since these two concepts form the basis of so many problems in mathematics and statistics. So understanding them very much well means having gone a length in understanding so many problems in mathematics and statistics. So we have come again today with some questions to solve with you with the intention that on the course of doing so, we must have made you to understand and see clearly the links which are necessary for you to navigate your ways, solving problems that have their tentacles or connections to logarithms of numbers and the indices. So we go over to the board. Permit me to call the questions up on the board, then we now solve together. This question says, and I write, number one. That question says, and I write, number one. It says, given that, log of 256 base what? X equals what? 2. Find log of 1 over what? X base what? 8. Look at how the question came. The question says, and I read, it said, given that log of 256 base x equals 2, find log 1 over x base 8. For us to be able to find this log 1 over x base 8, we must have known the value of what of x. And unfortunately, the value of x wasn't given here. So for us to know the value of this x, we revert to the information that was given to us earlier. And that information is that the log of 256 base x is equals to what? 2. So it is from this condition that we are going to get out the value of what of x and then plug into this what logarithm to be able to evaluate it. And how do we do this? What we do here is to quickly now change this logarithm now into indices. And see, as a way of solution now, see what I'm going to do. Let me divide this board into 2. So I have solution. In logarithms of numbers, when you are given a log in this way or format, and you are asked to convert it now into what? Indices. Watch what you do. You are given what? Log of what? N in base A. Log of n in base A. And you are to convert this log of n in base A into indices. What you do is, you equate this log of n to base A to any letter of your choice, be it x, be it y, be it anything. But it is more convenient for me to use x because it is x that is unknown which I am looking for in this expression. So I will say this is equals to what? X. This implies. To convert this into indices, it becomes the base raised to the power of that letter you equated it is equal to the number n. So this is what? A raised to power this what? X is equal to this what? N. I will say therefore, what they gave me here is a log of what? 2, 5, 6 base what? X. They say is equal to what? 2. So what am I going to do? I'm going to look at this x as if to say it were A. Look at this 2 here as if to say it were this x. Look at 256 as if to say it were n. So in that case, this will imply here is x raised to power 2. So I have x raised to power 2 is equals to what? 2, 5, 6. If you watch, what I was asked to evaluate is just ordinary x and not x raised to power 2. So I have to make interest. I have to make it as a point of duty to make x subject of the formula from here. And making x subject of formula here is taking square root of what both sides, which of course makes this thing to be, therefore, taking square root of both sides, I have that my root of what x raised to power 2 equals root of what 256. Square root of x raised to power 2 will leave me with x. This equals square root of 256 definitely will give me 16. Now I know the true value of this x, it is 16. Because it is 16 now, I will now come to evaluate this. I will now say, therefore, log of 1 over what? X base what? 8 is equal to now log of 1 over. You no longer write x because I have known that x is what? Is 16. So 1 over what? 16 base what? 8. Remember what we discussed earlier, that once we have log of n base what? A, we should quickly say we equate it into what? X, and then we now solve to evaluate it. So what am I going to do? I will say, therefore, my log of 1 over what? 16 base what? 8 is equals to what? X. And like what I did here, a raised to power x is equals to n. I am going to say 8 raised to power x is equals to 1 over 16. So I will say, therefore, 8 raised to power x is equals to what? 1 all over what? 16. And then this thing implies that 8 raised to power x equals, of course, 1 over 16 is just like 16 raised to power minus 1. So I have 16 raised to power minus what? 1. Of course, this 8 can be expressed into an index form as 2 raised to power 3. So in that case, I have 2 raised to power 3 for this 8, but I'm still having another x left here. This equals. I can equally express this 16 in an index form, which is 2 raised to power 4. So I have 2 raised to power what? 4. But because I have minus 1 here, that minus 1 will affect this what? 4. And what I have here becomes what? Minus what? 4. Now the base here is 2, the base here is 2. In indices, once the bases are the same at the left and the right hand side of what? A system of equation or equation, they can cancel off. So this and this is gone. And this implies that my 3 what? X is equal to minus what? 4. My interest is to get at the value of what? Of x. Okay? So what I'm going to do is now is all over what? 3. All over what? 3. So this will cancel this. I'll say therefore my x is equal to minus what? 4 over 3. Which is of course minus 1 whole number 1 over what? 3. Do remember that what x here stands for is not the value of this x that is here. The value of this x that is here is what? Is 16. What this x stands for what? Is the value of the whole of this. Because you said, let the whole of this thing be equal to this word x. And you now begin to what? To solve it down to this word line. Okay? I think most preferably I could have even used the y here. So it won't be a source of confusion in as much as we found the x earlier here. Okay? But then if you put in the y here now, if you solve, surely you arrive at this same value. So the value of the whole of this thing is minus 1 whole number 1 over 3 or minus 4 over 3. We really want to believe that you did not have a challenge as we provide a solution to this problem. We began from given that log of a 256 is x is equal to 2. We should find the value of 1 over what? Log of 1 over x is what? 8. So for us to be able to find this value, we need to know the value of x. And this value of x wasn't given to us. And of course, there was information preceding this. And that information that log of 256 base x is equal to what? 2. So from this information, we can know the value of what? X, with which to solve this problem. And then when I came down here and I said, for us to know the value of x now, we quickly transform this now into an indices. And to transform it into indices, to say x raised to power 2 equals to 256. The base raised to power the number you equated it to is equal to the what? The number. And the number is 256. So what I did here was what? x, which is this x, raised to power this 2, which is this 2, equals this number 2516. I need x and not x raised to power 2. Then I took the square root of both sides. This is square root of x raised to power 2, square root of 256. And this reduced to x is equal to what? 16. Because x raised to square root of 256 is what? Is 16. Now I've known the value of my what? My 16, my x. It is 16. Then I return back here. I will now say, therefore, log of 1 over x base 8 is now equal to log of 1, which is here. This x has become what? 16. So I now say 1 over what? 16. My interest now is to evaluate what the whole of this quantity is. So I came here and say, let the whole of that quantity be equal to what? X. So the moment I know the value of the true value of this x now, I have known what this is. Then I now came here. Just like what I did here. So I now say 8 raised to power this x is equal to what? 1 over what? 16. Which implies 8 raised to power x is equal to 16 raised to power minus 1. Because 1 over 16 and this are the same thing. Expressing this 8 in an index form, I have 2 raised to power 3x. Expressing 16 in an index form, 2 raised to power what? 4. But because of this minus 1, it affects this 4, it becomes minus what? 4. Now the base here is 2, the base 2, they can cancel. This and this has cancelled. What I have now becomes what? 3x is equals to minus what? 4. My interest is to get x. So I divide both sides with the coefficient of x, which is 3 and 3. So cancel off now to have this value. And with that, you are done solving that particular problem. So I really want to believe that I did not have much challenge in that problem which we solved. Permit us now to call up another questions and another question and solve with you quickly. Okay, that question becomes question number 2. Question number 2. Question number 2 say, given that 8 raised to power y over 4 equals to log of 16 base 2. Find the value of y. That is the question. He said, given that 8 raised to power y over 4 equals log 16 base 2, find the value of y. So the effort we are going to do here is, one side was given to us in what? In indices. The other side was given to us in what? In logarithm. And for us to successfully solve this problem, we either convert both sides to indices or we convert both sides to logarithm. But let us now try to convert both sides now to indices. By converting both sides to indices now, look at what we are going to do as a way of solution. Let me divide this ball into 2. So I will now have solution. Here is what? 8 raised to power y all over 4 is equals. Of course, you know that this 16 can be converted to an index number. That is 2 raised to power 4 is 16. So I can use 2 raised to power 4. So I now have that this is log of 2 raised to power 4 in place of 16 to base what? Base 2. But we are told in indices that whenever we have log of n base what? A raised to power x, that is log of a number raised to power x, is the same thing as using that power to multiply the entire log. So this is given as this x here times log of n in base A. This and this are the same thing in indices or in mathematics. That log of a number raised to a power is the same thing as that power multiplied by that log of a number. And if you understand what I have said here, I'll quickly come here and apply it. So this thing now becomes 8 raised to power y all over 4 is given as, here I am seeing this x this 4 as if to say it were what? X. So I'm going to use that 4 to multiply this. It becomes 4 times log of what? 2 base what? 2. Because I'm seeing this 2 here as if to say it were this n. Now we know in logarithm that log of a number to its own base is what? Is 1. So this thing has become 8 raised to power y all over 4 is given as what? 4 times 1, which implies that this is 8 raised to power y all over 4 is equal to what? 4. Because when 4 multiplied by 1, it is what? 4. What do? I quickly come here. This thing can be expressed in an index form, so it becomes what? 2 raised to power 3 into y all over 4 because of this. Is given as, here is 2 raised to power what? 2 for 4. So that I can cancel these 2 and cancel these 2 and bring down this. 3 times y is what? 3y all over what? 4. This is equal to what? 2, which I have here all over 1. Cross multiplying is 3 times y is 3 what? Y. 4 times 2 is what? Is 8. I'm interested in y. I will now say therefore my y equals what? 8 all over what? 3. Which of course you can convert to mixed number or you can leave it that way. So thank you very much for your time and for your audience today. We encourage you to always stick around us. Surely we are going somewhere and we are going to get there with you. Thank you very much.